Welcome back to another session. I should have taken off this jacket for continuity reasons, but never mind. So our session now is with Matthew from the Matrix Foundation / Element, and he's going to talk to us about end-to-end calling, end-to-end encrypted calling using Matrix, which is a really interesting topic. I obviously watched all of these being recorded. And I found it absolutely fascinating. So I don't want to hold that up too much, but I do want to say thank you to all of our sponsors, especially as Matrix / Element are one of our platinum sponsors. So let me just get my list of sponsors up in front of me. So we've got Subspace, Daily, Element. Matthew's here from Element today. And then we've got Mux as our platinum sponsors. Gold sponsors, Toulouse, 100 milliseconds Dite. Silver sponsors, Lowway, Sangoma, Millicast, WebRTC Ventures, and our community sponsors, Jambones, Telecurve, and Pion. And then all of our AV partners that help make the whole thing, help make the whole event run as it is they are PSP, Millicast, Broadcaster, Subspace, Element, Mux, and Me Echo. So I want to be able to talk to Matthew afterwards for about what he's talking about. So let's just go straight into his video, and then we'll catch up with Matthew and all of you afterwards.
Thanks, Dan, and it's a pleasure to be back at ComCon. I wish it was in person, but virtual is better than nothing. Thanks, Dan, for putting it together once again. So I'm here to talk about Matrix, as you might have guessed. This time, we're going to be talking about how we're doing decentralized signaling for group calls, multi-party calls in Matrix. And this is an extended edition of a talk for all the time that we have available to discuss it today. So if you don't know what Matrix is, we are an open source project defining an open communication protocol for an open network for secure decentralized real-time communication. So you can use Matrix for instant messaging, and you can use it for VoIP signaling. We've done a whole bunch of stuff for communications around VR and AR. You can even use it as a general purpose data fabric for replicating blobs of JSON, such as IoT data around the internet. And the network today is about 41 million users, spread over about 80,000 deployments on the internet. So not quite as big as the web or email, but we're slowly getting there. And lots of people use it, from Mozilla.org through to FOSDEM, through to ComCon, through to Red Hat, Ansible, KDE, GNOME, all sorts of exciting open source folks, as well as lots of governments and adjacent sort of private sector outfits who are building on top of it. So Matrix looks like this in a very simplified conceptual level, that you have a network of servers, which we call home servers. Each one has at least one client hanging off it. And so in this kind of simple diagram, you've got 3 servers, each with 3 or 2 clients hanging off them. And the novel thing about Matrix is that the data gets replicated equally over these servers. So that if this Matrix client in the top right is talking to a room where a Matrix client on the bottom left exists, and their messages end up a bit like Git, getting replicated equally between the 2 servers. So there is never a single point of control or failure for those conversations. As an ecosystem, what we provide is the Matrix spec, which just got a major release of 1.1 and a whole new website at spec.matrix.org. And this is the kind of crown jewels of Matrix. It goes and defines how the clients at the top go and talk to the servers at the bottom, and also how the servers talk to one another. We provide a Python implementation called Synapse. There's a Go implementation called Dendrite. You've got bridges that connect through to lots of other networks like SIP or XMPP or IRC or Slack or Teams or Discord, etc. Then you've got client-side a JavaScript and TypeScript stack, an iOS Swift and Objective-C stack, Android Kotlin stack, and then we also have next-generation stacks like our Rust SDK and Hydrogen, which is a super lightweight progressive web app. On the purple side, we have community projects which come from people building on top of the standard. And these could be servers like Conduit, which is an excellent matrix server in Rust, or it could be clients like WeChat or NeoChat or Fractal or Quaternion, or basically hundreds of different matrix clients out there. So if you're not familiar with the matrix ecosystem, it's really quite a fun sort of smorgasbord and melting pot, if you will, of people going and building open communication solutions. So WebRTC signaling in Matrix today looks like this. If you've got a user called Alice on alice.com going and talking to a user called Bob on bob.com, then Alice's client will go and open up WebRTC and get an SDP offer, which it puts in an m.cool.invite matrix event, which is a little blob of JSON that gets passed over to her server, which gets passed to Bob's server, and then makes it through to Bob's client. She will then trickle through some ICE candidates afterwards, because we have trickle ICE as a native sort of citizen in Matrix. Bob will hopefully answer it. We'll trickle back some other ICE candidates, and Alice will select which answer from the various possible Bob devices that Bob might have she's talking to, and then WebRTC flows back and forth. Eventually, one or the other side will hang up. So it should be pretty familiar to anybody who's done signaling with SIP, or indeed just any kind of WebRTC signaling. The only difference is that it's standardized and it works in this decentralized cross-network capacity using HTTP for the signaling. Now, for group call signaling, we started off with the idea that each room had a single predefined multi-point conferencing unit as a focus, i.e. a conferencing server that participants could call into via as a normal one-to-one matrix call, but going over a bridge. And for this, we use FreeSwitch as a nice conferencing server, which has a protocol called Verto, which is JSON tunneled over WebSockets. And I wrote a little node bridge that taught Matrix on this side, on the application service protocol, and then Verto on the other side, talking through to FreeSwitch. So if you had a chat room where all of these servers and clients exist, and somebody hit the video call button, in practice, all of the clients would go and call through to FreeSwitch to be conferenced together. It worked relatively well, except we found ourselves wanting a richer user experience on the client. We wanted to have the more sort of dynamic, responsive UI for conferencing that people are more used to with WebRTC. And so we switched over to using Jitsi. So Jitsi, I'm sure everybody is familiar, is a selective forwarding unit architecture where you have a Jitsi video bridge, which goes and routes some streams of media between different connected clients. The clients run a little web app called Jitsi Meet that goes and looks like Hangouts or your other favorite WebRTC-based conferencing tools. But it uses Prosody as a signaling server. Prosody is a very good Lua-based XMPP server. And you have also a conference-focused component, which is controlling the overall sort of architecture of who's talking to who within Jitsi. We end up implementing a bit of Lua here, which would act as a access control system that plugs into Prosody. And then we also have Matrix user verification service, which isn't a bridge, but is basically gluing together the access control in Matrix with the access controls in XMPP. And in practice, all of the clients just embed Jitsi Meet as a URL in their room, because Matrix has the concept of widgets where you can take arbitrary HTML content and embed it into a chat room. So it could be Grafana, or it could be, I don't know, GitHub, or it could be just a Jitsi video conference. And if your client has native Jitsi support because it links against React Native Jitsi SDK on iOS and Android, like Element iOS and Android do, you get a native experience. And it works pretty well, and that's how it works in Matrix today. But there are some fairly big problems with widget-based conferencing. Critically, unlike everything else in Matrix, it's not decentralized. So whatever Jitsi is picked as the focal point and the provider of that Jitsi becomes a single point of control and failure for everybody on that call. So even if you're using a really funky hosted Jitsi solution with Octo-style cascaded conferencing servers, it's still going to be sitting on a single domain run by a single party. And if things go wrong and it gets overloaded or its provider goes down, it's not going to be good news. Also, as you saw, there are a lot of moving parts here. Because Jitsi doesn't use matrix for its signaling, you end up with this whole separate parallel XMPP stack, and we had to do this nasty glue with Lua to go and sellotape together the access control that you get in matrix, which is incredibly fun. It's like one of the biggest academic novelties in matrix, that you get decentralized access control that we then centralize, glue into prosody, and try to marry up the XMPP access with the matrix access. It also doesn't interoperate with one-to-one matrix calls. So it's a really strange user experience in matrix that if you're in a DM with somebody and you hit the video call button, you immediately jump into this one-to-one native matrix encrypted call. But if you've got more than people in the room, more than one person in the room, it goes and fires up a Jitsi instead. And there's no way to transition between the two. And the encryption is end-to-end encrypted in Jitsi these days if you turn it on, but it doesn't leverage any of Matrix's verification or identity model, because again, in Matrix, we've got lots of fun stuff to verify that you're actually talking to the device that you think you're talking to, that you've gone and scanned a QR code of the other user, or you've compared some emoji out of band in order to ensure that you're talking to the person you think you're talking to, and then we just throw it all out the window the second that you hop on a Jitsi. So, why hasn't anybody ever defined an open standard for group signaling before? And it reminds me a bit of the early days of Matrix, when we sat around thinking, why hasn't anybody done an HTTP-based messaging protocol before? It's an obvious thing to do. Why hasn't anyone done it? And we don't know what the answer is. If anybody knows of such existing open standard for group call signaling, please tell us, because I think this is the first one. What would matrix one-on-one signaling look like if we just extended it to work for groups? Well, the answer is that we can extend one-to-one signaling for group calls. So to define some terminology, we are adding the concept of conferencing servers into the mix here, but we call them foci, i.e. the plural of focus, because focus is just sounds silly. Foci here are servers which could be SFUs, selective forwarding units like Jitsi, or MCUs like FreeSwitch, which could be run by completely different people on the network, and they form a genuinely decentralized call fabric, and it doesn't force any particular topology or architecture for these group calls. So if there are SFUs available to the clients in a given call, they can be used. And if there are MCUs available, they can be used too. And if you don't have either, you can just go full mesh, old school, and just go and set up a bunch of one-to-one calls between the various different clients. And so you will always be able to get a group call at some level of quality to work. But basically, the different deployments can just throw in more server capacity for their users, or indeed to provide for other users too, in order to scale things out. So the clients pick the foci to use. Could be the ones from their server. Failing that, could be ones advertised by other people in the room. And in practice, the foci just beat Matrix. It's just normal one-to-one calls, and they exist as Matrix endpoints. And the end result is that you get massively scalable, cascaded, but decentralized SFUs and MCUs. So for all the gory details, please go and check out Matrix Spec Change 3401. Go and look it up on Google, and you'll discover that yours truly going into excruciating detail about the Matrix and sort of fine detail. But at high level, it looks like this. So same diagram as before, but now we've said that each server deployment is going and bringing at least one or zero, really up to them, foci or focus to the party. So we've got 3 foci here, each one associated with a different server, and the clients go and get conference together on the local foci, and then the foci go and trunk together in a full mesh and go and forward the streams which the other foci require in order to basically build out this decentralized conference. So the signaling looks like this. Alice goes and sends a new state event called m.call into the room that she shares with Bob and Charlie on their respective servers. She then says, as well as starting a conference, she's going to join it. So she sends an m.call.member state event to say that she is a member of the call. Then say if Bob wants to join too, he goes and sends a membership event, say that he's also joining that conference, at which point Alice knows that she can do an invite to him. He'll answer it, and SRTP will flow as normal. So this is actually just showing a full mesh for simplicity. If you put an SFU into here, the sequence diagram is completely impenetrable, and you can't read it because the text gets too small. But here we're going to show off just simple full mesh. And then if Charlie later on decides to join the same conference, then not only will Alice go and initiate a call with him, but Charlie will also end up receiving a call from Bob, and you've established a three-party full mesh call using a standard signaling protocol. So just to recap, the initiator creates this m.call state event. It tracks whether the conference is a voice or video call, but also should it ring the devices, like if it was a one-to-one call, or should it prompt people to join, like it is a, I don't know, Jitsi and Matrix today, or should users auto-join to the conference if they're in the room, like you have in Discord, and provide voice or video rooms. You also get a label for the call instance. It then also advertises in this event the foci of the person who's initiating the call, if that user knows about any focuses. So they could say, hey, you can go and hop on this call by joining my SFU at like, I don't know, SFU on lon.matrix.org or something. And then anybody else who joins the conference, if they don't have their own foci, can hop on the one which is advertised there. Then you've got the m.call.member events, which state who's in the conference, and it also tracks what foci they are using. So again, these foci can be discovered by other people in the conference. And it also tracks the media streams which that user is sending, the media tracks that they're sending within that stream, and also the settings that describe the format of the tracks which they are sending. And they could also include in future whether this media track is a composite of others, if they're acting as an MCU. So when we practically speak, as in foci, we don't have this running yet, so it's slightly vaporware on the SFU side, I'm afraid, but we're actively working on Iron SFU, which is a Golang SFU built on the excellent Golang Pion WebRTC stack, and we're gluing in matrix signaling to it as a transport because it already supports pluggable transports using Go Maltrix, which is an excellent Golang matrix stack. And then we're also, however, looking at Media Soup, which is the SFU used by Mozilla Hubs. Now, the guy who's been doing most of the development on this is called Robert Long. He used to work at Mozilla Hubs and has a lot of experience of using Media Soup as an SFU for their use cases. And what he's looking at doing is hooking it up with our normal TypeScript Matrix.js SDK signaling library and exposing it with this protocol so that you can also plug media soups together. So in an ideal world, we'll finish off both of these, and you can pick whether you want to use media soup and JS SDK or Iron SFU plugged into Go Maltrix in order to provide your matrix compatible decentralized conferencing capability. And if you're writing your own SFU or MCU, or if you're working at Jitsi and you want to abandon XMPP signaling and move over to Matrix, then you could also obviously hook this up too. So right now we're selecting to use what we will be using for our own deployments, Element, who is funding all of this work for Matrix. We haven't done any MCU experimentation yet. It's still all about SFUs. And the kind of rule of thumb that if you are a client trying to decide which focus to use, if any, first of all, if your server has provisioned you with a given focus, you should call it. And if not, you call the nearest one from others m.call.member events, nearest being defined by latency. So we need to have some mechanism. I forget what we recommend. It's probably latency of the RPC over data channel, which I'll talk about in a minute, that will reveal to you which are the physically closest, or at least the latency-wise closest focuses to use. And if you don't have any focuses or foci in the conference at all, then you just call the other endpoints for mesh, like I showed in the sequence diagram. Calls to the foci are just plain matrix one-to-one calls. So they have matrix IDs like SFU on nyc.matrix.org or SFU on london.matrix.org. And each SFU can cluster by going and having multiple devices which are sitting on the same account. And so when you go and place a call to it, you would select one of those devices, or perhaps you call all of them to get a sort of basic load balancing in place. But the fun thing is that the calls to the foci just can have lots of inbound streams. And this could be simulcast, or it could be poor man simulcast, i.e. simultaneous unicast streams, really to be decided which, or if both, we go for. And the idea is that as a client, you would select from your stream forwarding unit or your focus and say, hey, I want to get thumbnails of Alice, Bob, and Charlie, and I want to get full screen video from Dave and Emma. And you make those selection requests via the data channel. Again, plain old normal WebRTC data channel established between your client and the focus. And we've specified a very simple JSON protocol that allows you to put requests. Basically, you can select a stream, and that's the only command that you have. And you know what streams you are available to receive because they're advertised in the matrix room state in these m.core.member events. The foci plug into Matrix as application services, which means that they sit there sniffing the room for the events that happen, the m.call and the m.call.member events, to see what other foci exist and to make sure that they call each other so that the mesh links up between the foci. So you can think of this effectively as being full mesh between the focus points of the network. So the people on their respective servers, whether they're run by the same organization or run by different ones, will all go and clump together and call each other, trunking the calls effectively between each other in a mesh. If we hit scalability problems there, then we will figure out a way to have better than full mesh routing. And honestly, by that point, I'm hoping that the peer-to-peer matrix stuff that we actually introduced last year at ComCon will be at the point where we already have an overlay network available that maintains a spanning tree between the nodes on the network, and we can go and route the traffic through that spanning tree to literally have a beautiful tree-based cascade between the various different foci. But for now, we just do it full mesh, which for typical rooms, I think will be fine. Finally, end-to-end encryption will be provided using good old insertable streams, which by the time we've hit this up, hopefully will be very commonplace everywhere. Nowadays, I guess called encoded transform, and using S-frame as a way to encrypt and packetize the actual frames that are being forwarded through. Obviously, the key management will be good old matrix, Olm and Meg-Olm, like everything else. And so we leverage and build upon the existing encrypted end-to-end encryption that we get in Matrix. And for full mesh, we already get this for free because they're plain one-to-one calls between the endpoints. And the other big change that we have here is that Matrix is changing signaling transport entirely for how the VoIP signaling works for this. So today, as you go and throw these one-to-one signaling between users in a given room. If you've got a single room with Alice and Bob in it, then the m.call.invite and m.call.answer and hang up, etc., get persisted as full JSON events in the conversation history of that room. So this is kind of useful for a one-to-one call because it gives you CDRs for free. It gives you the call history, and it's all nicely interleaved with the spoken, the instant messages and the files and everything else in that room. And it felt very much like the right way to do it for one-to-one calls, and that isn't going away. However, for a group call, you really don't want to see the other user's signaling in detail. I mean, it completely wastes your bandwidth because it's irrelevant to you. It's a real privacy hazard because you're going to get IP addresses in that SDP, which are now being persisted in the room in perpetuity. And finally, when we started off implementing it like this for the full mesh group calling, we found that it basically drowned out the relevant signaling, and we had embarrassing bugs where the client would fall behind the server sufficiently that it would have to backpaginate to fill in the gap of history to find the VoIP signaling for the calls that it cared about, because there was so much other chatter going on in the room as all the other clients set up their full mesh stuff to each other. So what we have done in MSC 3401 is to switch to what we call two device messages. And this is the API you get in Matrix for very simple store and forward messaging from one device to another. So it doesn't happen in the context of a room. It's literally saying, hey, I've got an endpoint, which is a phone on Alice's account, talking to a browser on Bob's account, and here is a JSON blob that I just need to get from A to B as rapidly as possible, caching it on the server and forwarding it on if Bob is currently offline. And we use this today almost exclusively for establishing one-to-one end-to-end encrypted channels between devices using Olm and Meg-Olm. Here we have extended it so that it can also transport WebRTC signaling using the standard m.call.invite events. And we tunneled these events over the one-to-one Olm channels, which gives us perfect forward secrecy for end-to-end encryption for the first time, because MegOlm isn't technically full PFS. So much better privacy semantics. Not only is it perfectly forwardly secret, but also it's not being persisted anywhere, and it's only going to precisely the endpoints that really care about it. So in terms of lessons learned building this, first of all, you can play with this right now. A test client should be up, matrixvoip.dev, which we are rapidly extending into a real full sort of product. I'll go and show you it in a few minutes. Right now, we've only done full mesh, but on the plus side, that is working incredibly well in all major browsers. That is Chrome, Firefox, Safari, and Edge, including mobile Safari. Safari has been a complete pain in the ass to work with, particularly working around the fact that you can't call get user media multiple times for your full mesh. So instead, you have to call it once and then clone the resulting media stream, but then you need to keep replacing the media tracks within that stream to stop them going inactive, because otherwise mysterious things cause it to mute or go inactive or hang up as the various different calls do their thing. I think we've got it basically robust now, but it's been, we lost at least a few weeks battling that. Also had some fun with CSS animations on video tags and mobile Safari. Turns out that if you transition the width or height attributes, the frame rate goes from 30 to 2 frames a second. So we've worked around that. Also burnt some time working through glare problems, and I've completely skimmed over the question of how the various different participants in the conference know who to call and whether Alice should call Bob or Bob should call Alice, what happens if Bob hangs up and comes back in, who should reinitiate the call, all that sort of thing. And honestly, that's slightly in flux right now. And what we actually do is to deliberately glare every call setup. So Alice calls Bob at the same time that Bob calls Alice, and whoever wins that glare wins. It's not ideal, and I think that we can put some heuristics in place to improve the glare semantics, but it's not quite there yet. Will be by the time the MSC hits the spec properly. And finally, all of this is quite unashamedly an excuse to build decentralized SFUs for a decentralized metaverse. And long-term Matrix followers will know that we've been off trying to build multiverse, metaverse-style experiences on top of Matrix since day one. In fact, Matrix was originally codenamed Third Life as an experiment in what would happen if you did Second Life, but better. And in order to build that, we needed to build a communication protocol. That's where Matrix came from. And gee, can you see why we might have picked Matrix as a name now? Either way, having building blocks at last for proper decentralized VoIP and video in Matrix should be quite transformational in terms of building out a proper decentralized metaverse on top of Matrix. And Robert, who's been working on all of this, has a side project already called thirdroom.io, which is building out VR experiences using this as the signaling plane. So that's it for the main story. I'm just going to try to squeeze in a quick demo here. And here is matrixvoip.dev. And if I go and enter this call, I'm just the first person in the room. So I've gone and put in my m.call, I've sent in my membership event, and you can see that the room itself is called ComCom Demo, which has got, interestingly, a URL on a different server. So this is matrixvoip.dev, but I've joined a room that was created on robertlong.dev, which is a different server. And it's the one that I have sitting right here, robertlong.dev. Now, if I go and refresh that and hit allow, then you can see I'm hopping on with WebRTC in mobile Safari, like so. So now I'm in a one-to-one call effectively within here. But here is another laptop I have ready to go. I'm going to hit enter call there as well. And now we're in a full mesh. So, ladies and gentlemen, this is the future of calling in Matrix. And you can see how snappily it came in. The fact that the WebRTC quality here on mobile Safari is looking great. Other things I could quickly show you is that I could like screen share my whole screen like that, and you get a comedy layout of everything. We can do screen shares from multiple places at the same time. So then on my laptop here, I could go and also share my screen here as well. Now you've got two of them side by side. And if I hold this up to one of my cameras here, hold it up to this one and zoom in on that one like so, then you can, oh yeah, there you go. You can see that we've even got the two screen shares coming up here on iOS, and I can relay it out nicely, and you've got all these beautiful CSS transitions going on as you can go and relay things out in different ways, complete with interesting layout bugs like that. So there you go. That's the feature of group calling in Matrix, and I hope that people will be interested in building on it and using it as a building block in future. Thanks very much, and enjoy the rest of ComCon.
Thanks for that, Matthew. I'm just going to bring Matthew in now. Thank you very much for sponsoring ComCon again. You guys have always been huge supporters of what we try and do, and that's doing something different, and that's what Matrix is, and that's what Element is. So we had a question in the. I want to get straight to questions, but we had a question in the chat, asking about getting Janus involved. So I want to broaden that a little bit and say, well, if someone has an open source media server implementation, how can they go about getting involved with this effort, so that everyone can play nicely together?
Excellent question. Thanks, Dan, for the opportunity to come on ComCon again, and it's a pleasure to be able to support again. So yeah, excellent question from Lorenzo originally about getting Janus to talk this new protocol. The whole point here is to try to provide a standard communication mechanism between the different SFUs and indeed different MCUs out there. So we happen coincidentally to be playing with Media Soup and Ion SFU right now. The only reason we picked them is that Ion SFU is very close to an existing SIP to Matrix gateway that we have ourselves, so we can kind of steal some of our Go stack, and likewise on Media Soup, it's very close to the Mozilla Hubs thing. But we really like Janus, and we like a lot of other SFUs out there too. And in fact, I think I implemented Matrix support for Janus many years ago, which was has bit rotted. We were just looking at the code in the chat room. It's about 7 years old now. But the idea is that anybody should be able to look at the MSC 3401 and see that it's actually very basic. It looks and feels a lot like typical SIP or even JSAP style underlying WebRTC signaling. And it's just defining a standard way that you can do selective forwarding of streams between things. So I'm hoping that Lorenzo and the Janus guys will definitely look at it and see how easy it could be to plug it in as a transport to the existing modular transports there. And indeed, anybody else with an SFU, probably less a media server, but particularly good for SFUs right now, might jump on board too. Perhaps even the Jitsi guys will.
Hopefully. Well, thank you very much, Matthew. I know we've got other sessions this week from the Matrix team, Element team, which I'm really looking forward to as well. But it's always nice to have you on without talking at a huge rate of knots that we're used to. So thank you very much for joining us and sharing something new. So everyone that's watching live, thank you very much for watching live. And if you're on YouTube, then make sure to like and subscribe to our channel. And then you'll get a nice, if you press the little bell icon, you'll even get a nice notification when we put videos live in the future. Wink, wink, nudge, nudge. Anyway, I digress. So we shall see everyone later for some more sessions, and have a good afternoon.